Hi, my name is Mayank Sharma, and in the following video, I will be solving the second question assigned for the end term evaluation for subject code MAT104, that is Mathematical Methods 2. So, yeah, let's go ahead and solve the question. So, in this particular question, we are supposed to um, derive the condition for which this equation would be an exact ODE, that is ordinary differential equation, and then solve it. So first thing first, let's have a quick look on what an exact ODE is. So a differential equation of the form mxy, basically a function m of x with considering the both the constant x and y, dx plus n x y dy is equal to 0 would be considered an exact differential equation if there exists a function uxy such that du is equal to mxy dx plus n xy dy. Since du, and if we compare these two equations right here, what we get is that du is equal to 0 implies u xy would be equal to c, that is an arbitrary constant, and this would be our general solution for an exact differential equation. So let's head straight, and so another thing that we see that as we know already that du could also be written as dou u by dou x, partial differentiation with respect to x dot dx plus dou u dou y dot dy, and comparing these two right here, what we get is dou u by dou x is equal to m, and dou u by dou y is equal to n. And as we know by the equality of the partial derivatives, also known as Young's theorem and also known as Clairaut's law, if I'm pronouncing it right, I'm pretty sure I'm not, that dou 2u by dou x dou y is equal to dou 2u by dou y dou x, that there is a symmetry here. So comparing with these, what we get is that dou m by dou y would be equal to dou n by dou x. From this what we get is that if this condition is satisfied, then we can say that our equation right here is an exact ordinary differential equation. Sure, there are many other conditions too. For example, the differentials of m and n should always be continuous throughout the range we are considering solution. Same goes for u. The differential of u should be continuous throughout, and if differential is continuous, so should be the equation itself. So yeah, this is what we have got. So let's keep it aside for further reference while we will be solving the main problem here. So first thing first, what we're gonna do is rewrite this right here for our favor. What we get is ax plus by in bracket dx plus kx plus ly dy is equal to 0. And let's first thing first, what we need to derive as a condition so that the this given equation, in this given differential equation, is an exact ODE. So yeah, if we compare with these, we get m right here is equal to ax plus by, and n is equal to kx plus ly. So as the condition of exactness was given, dm by dy should be equal to dn by dx, dow x, sorry, partial derivative, so that's what we are considering here. So let me recite it once again. That would be dow m by dow y should be equal to dow n by dow x. Let's solve it. Partial derivative, what we get is dow m by dow y, that would be b, should be equal to dow n by dow x, that would be k. B should always be equal to k. This is a condition that is going to that would determine, that would make this equation right here an exact ordinary differential equation, and the other conditions are what we're keeping aside, because we are expecting that all the derivatives would be continuous throughout the range of solution we are considering. So let's replace k with b and rewrite this equation, the equation number 1. If we say, what we get is ax plus by dx plus bx plus ly dy should be equal to 0, and the general solution, our general solution would be uxy, and yeah, as you have already seen, du is supposed to be, so let's get back to what we are supposed to do. Let's consider this particular equation right here once again and integrate it. Like basically integrate would be too much of a term. What we can say is, let's find an antiderivative. That seems pretty much more appropriate. What we get is u would be equal to mxy dx, we are integrating with respect to x, plus ky, cos as we are integrating with respect to x, if the change is in pure y, we might treat it as in constant, cause what we are considering right here is the change in the equation with respect to x. So there would be a function of y that would be a constant here. So yeah, first thing first. And what's the next step? What would be our next approach if you go so first thing first, let's find out the value of u from this approach, and would be m bx plus ky, that is any function of y, could be a constant, could be pure y. That would be basically what we're going to get. So what we get, that u is equal to ax plus by dx integrated ky implies u is equal to ax square by 2 plus bxy plus ky. And as you already know, we have already compared, as well already know, let's reference it once again, that du by dy would be equal to n. Instead of dow u by dow y, we can straight up write du by dy, and no, what we're going to do is write dow u by dow y, seems more appropriate. Yeah, dow u by dow y would be equal to n, so let's write it again. Dow u by dow y would be equal to n. Let's keep it aside, and since dow u by dow y is equal to n, implying as you know, u was equal to ax square by 2 plus bxy plus k was a function of y, what we get is bx plus dou k by dou y equal to n. The value of n was bx plus ly, considering the fact that k was basically considering the fact that b was equal to k. So yeah, for bx what we get is dou k by dou y. Yeah, another thing was that k would be pure a function of pure y, like it would be a constant, or there would be only y. X is not involved there. So instead of dou k, we can straight up write dk by dy is equal to ly, giving us dk, giving us k is equal to ly square by 2 plus c dash, because we might need to alter the constant. So c dash is not what we can say, constant basically. So yeah, this is the third. Consider this as the second part. So putting the value of, let's say, ky in this equation, value of ky in this equation, what we get is that uxy is equal to ax square by 2 plus bxy plus ly square by 2 plus c dash. And as we know, uxy, the general solution, is equal to 0, implies ax square plus by 2 plus bxy plus ly square by 2 plus c dash equal to 0, implies that uxy is equal to ax square by 2 plus bxy plus ly square by 2 equal to c, would be the general solution of the exact ordinary differential equation, this. So yeah, that's our solution.